Good morning, everybody. Welcome to the presentation on software project management. And today, in this presentation, we're going to focus on metrics for process and projects. Outline. So, for this talk, this is the proposed outline. First, we'll talk about measurements. We'll talk about measures. We're going to talk about metrics. Then we'll get into software metrics, focus on the project and process metrics. And then we'll also touch base an overview of what are software measurement or software development measurement metrics. Then software quality or testing metrics, and end the presentation with defect removal efficiency. Introduction. A software process is a structured set of activities for developing software, typically including specification, design and implementation, validation and evaluation. Next, what is software project metric? Software project metric are quantifiable measures used to assess and manage the performance of a project, covering aspects like cost, schedule and productivity. Software processes and project metrics are quantitative measures, and these enable software engineers to gain insight into efficiency of the software process and project. So it will help them have an overview on how the process of the software development cycle is actually happening. Then basic quality and productivity data are or AKA or also called measures are collected, analyzed, compared and assessed. Metrics also indicate problem areas during the process and project as we proceed in the project cycle. Next, reasons to measure. What are the main reasons to measure? So one is to have an idea as how the entire process is actually happening. For instance, when we are looking at the software defects, so while testing, if we identify more defects, we'll see that we have done a fantastic job fixing the bugs before they are reported by the end user. So that's one of the reasons why we have measures which help it succeed. So here the reasons to measure is first to characterize the data, gain an understanding of the process, product, resource or environment. Next, evaluate, that is determine the status with respect to plans. Predict, gain understanding of relationships and improve. Identify the roadblocks, root causes, bugs, inefficiencies, defects and other opportunities to improve the quality and process performance. Next, metrics for project management. So there are many metrics out there for project management. They're segregated into budget, schedule, resource management, risk management, project goals, customer satisfaction. And metrics here would be budget, cost, work schedule, budget, cost, work performed, actual cost of work performed, budgeted completion, cost performance index, estimate at completion. These are some of the examples for project management metrics. Next, metrics of software product. So metrics for software product are a holistic view of the entire software product. The metrics are categorized into size, error density, defect density, and so on. Size metrics here include like function points, then lines of code, modules, pages, documents, and so on. Characteristics of software metrics. So what are the different characteristics of the software metrics? First is quantity. Metrics must possess quantitative nature. It means metrics can be expressed in values or numbers. Understandable. Metrics computation should be easily understood and the method of computing metrics should be clearly defined. Applicability. Measures should be applicable in the initial phase of the development of the software. Repeatable. The measure values should be the same when measured repeatedly and consistent in nature. Economical and language independent. Benefits of software metrics. So benefits of software metrics are first return on investment. It helps to identify areas of improvement while the process is going on. It helps you to efficiently manage workload so that not everybody is put under pressure or on point, and reduce overtime. So it helps you to identify bugs and fix them before rather than waiting for it to come at a later stage and take more time to fix, and reduce costs. By being effective identifying issues, fixing them, cost or losses are reduced. What is return on investment? Return on investment is a performance measure used to evaluate the profitability of an investment by comparing the net profit or gain to the cost of the investment expressed as a percentage. So these are some of the benefits of the software metrics. Next, definition. First, let's define measure. Measure is a quantitative indication of extent, amount, dimension, capacity, or size of the attribute. Metric is a quantitative measure, something that is derived from measure, which is used in a system, component, or a process given. Why measure software? The reason we measure software is to determine the quality, predict uh, qualities, and improve the quality of the product or process. Motivation for metrics. Estimate the cost and schedule of future projects. Evaluate the productivity impact of new tools and techniques while the software is being developed. Establish productivity trends over time. Forecast staffing needs. So these are some of the things that motivate why we need to have metrics while we are in the software process or project management. What is measurement? It is the act of obtaining a measure. It's a mechanism of object evaluation. It enables practitioners to improve software processes, and it also assists in planning, tracking, and controlling the development of the software. What is a measure? Difference. It produces a quantitative indication of the size of the some product or process attribute. Metric is a quantitative measure of the degree to which a system, component, or process possesses a given attribute. Let's look at them here. What is the difference between metric, measure, and indicator? Simple. So a metric is a single directly observable value or quantity. Measure is a single directly observable value or quantity. Metric is a quantitative measure derived from one or more measures, providing context. An indicator, it compares a metric against a baseline or expected result. So what it means is measure is raw data, metric is calculated data, and indicator is strategic data. So yeah, a measure is a raw quantifiable value. A metric is a calculation that uses one or more measures to provide context. An indicator is a metric that is directly tied to the strategic goal, showing progress towards it. In short, a measure is a number, a metric puts the number in context, and an indicator shows if you are on track or target to achieve an objective. Next, determinants for software quality and organizational effectiveness. So then we have three important factors: product, people, and technology. So people and product, the process that would give the overview is customer characteristics. Product and technology, when we analyze the process, we identify business conditions and we build metrics on top to help business achieve its goals. And people and technology, the development environment. Process metrics and software process improvement. To improve a process, first we need to measure specific attributes of the process, develop meaningful metrics based on these attributes. These metrics provide indicators that lead for strategy for improvement. For example, metrics can be derived from the following processes, like errors uncovered before software release, during the testing, or defects delivered to and reported by end users. So these are some of the examples of metrics. Project metrics. So project metrics used by project managers and software teams to adapt project workflows and technical activities. So these metrics, the objective is to minimize the development schedule, assess product quality, and use metrics to estimate time and effort. Next, project metrics. Example for project metric is metrics collected from past projects help to establish time, and these can be used to estimate efforts of the current project. So for instance, you are building an application called customer relationship application, a CRM application. So the last version, you have an idea is how much time it took 1 year to build it. So using this and the breakdown of it with the new features adding in helps to estimate the time taken to finish this future project. So that's an example. Next, software projects are assessed against the project metrics for improvement. Software measurement category. So direct measure of software process is cost and effort. of product or lines of code, execution speed, defects over specified period of time. Indirect measures are for a product for the product functionality, quality, complexity, efficiency, reliability, and maintainability. Next, size-oriented metrics. So size-oriented metrics are derived by normalizing quality or productivity measures by considering the size of the software. LOC, lines of code. This is one of the most common size-oriented metric because you are estimating the number of lines of code written to get an objective done, and you measure it per user, you measure it per month, you measure it on time and usage uh, criteria. This is widely used in the industry. Size-oriented metrics are very common with the software development and product management folks. Next, examples for size-oriented metrics are 1,000 lines of code, KLOC, errors per KLOC, defects per KLOC, dollar for LOC or the cost per LOC, pages of documentation per 1,000 lines of code, errors per person per month, then lines of code per person per month, and dollars per page of documentation, cost per page of documentation. This is some of the examples. Next, function-oriented metrics. This uses a measure of functionality delivered with the application as a normalization value. So this is a complex method which is it is debatable. It is not a solid measure, but this enables the manager or the lead who's doing this calculation to come up with function points in the entire code. So you calculate the function points, put the values into a formula and do it. Function point is first proposed by Albert and can be used to measure functionality delivered by the system. Like LOC, function point is controversial. So for people who support it, say that it's program language independent, hence ideal for conventional and non-conventional languages, and it is based on data that is known early early in the phase of the project. But what the people who disagree say that it is just a number and has no physical meaning. The function point. The formula used to calculate function point is count total into 0.65 plus brackets 0.01 into sum of uh, function points. So some of the uh, so so yeah, this itself is a very dedicated concept to dwell in and explain. So this has a special session on its own, and we plan to cover it in the future talks. But remember, with the function point, we can calculate more measures on top of it, like productivity is equal to function point by person per month, quality is number of faults by function points, cost is cost by function point, documentation is pages of documentation by function point. This is some of the metrics that can be done with it. Next, object oriented metrics. So this is by software development metric and used by object oriented projects. So this has a lot of other metrics in this, like number of scenario scripts, number of key classes, number of support classes, so on and so forth. Use case object oriented use case oriented metrics. So these metrics are use case derived. So we write use cases for the product based on the functions and features you calculated. For instance, size of application in lines of code is one of the use case oriented metric, or number of test cases that will be designed. These are some use case oriented metrics. Next, software quality metrics. So measuring quality, there are various categories to it. First is correctness. Correctness is the degree to which uh, software performs in a required function. So what we can say is for quality metrics, defect can be defined as any problem or lack of conformance to requirements reported by customer or user after delivery. And software quality metrics are generally testing metrics. For instance, correctness, maintainability. It is correct. It is the ease with which a program can be corrected or adapted or enhanced. Next, integrity, system's ability to withstand attacks. That is it. Usability. It quantifies ease of use and learning time. Last, here we come to defect removal efficiency. Defect removal efficiency is used to quantify how many defects were found by the end user after product delivery in relation to the errors found before product delivery. So de- defect removal efficiency is number of errors found before delivery by number of errors found before delivery plus number of defects found after delivery. That is DRE. Next, advantages of software metrics. Reduction in cost or budget. So when you have metrics in place and you're measuring the progress of the project or the product, what we see is we look at various ways to reduce cost in terms of having more testers or more developers. Assigning the people will help to reduce the cost. Next, it helps to identify the particular area for improvising. So based on your metrics, you can see in test when you're having metrics of software quality and you identify that there are more number of bugs caught, that means it helps us to improve the performance of the testing and achieve the product at a very appreciable level. This is the thing. Next, it helps to increase the product quality and it manages the workload and teams. So once you have metrics in place, you see who's contributing, who's not contributing, which developer is performing well, which tester is performing well, or who is consuming more time, and so on and so forth. These will overall help to increase the product quality. Managing the workloads and team. Next, reduction in overall time to produce the product. So without having metrics, if you're blindly going ahead, then you don't have an idea on how much time you will take to finish it. But once your metrics in place, you have a definite measure where you're measuring the progress as you go forward. So reduction in overall time to produce the product. Next, it helps to determine the complexity of the code and to test the code with resources. So this is by default. You not explain this here. Uh, by using this metric, you can see how well you are doing. And it helps in providing effective planning and managing of the entire product. So once you have an idea, for instance, you're developing a software uh, uh, which which processes, it's an email application software. So what does it with the metrics in place as you're moving forward? First, you'll have planning and project phase, so project management uh, metrics. Next, you'll have software development metrics. Then you'll have testing metrics. All this helps you to have an effective planning and management of the entire product. Next, what are the disadvantages of software metrics? So software metrics, there are not just advantages, even disadvantages. And disadvantages happen because if you don't plan effectively and if you don't have well-defined metrics, you're just using a metrics for the heck of using it, then you'll not be able to have uh, appreciable results. So one, it is expensive and difficult to implement the metrics in some cases. So in some cases, when you're going with projects with more than 20,000 function points, so that's a huge project and there'll be many people involved, large teams, multiple engineering teams. So it's expensive and becomes difficult in some cases. But if you have a well-defined set of project managers or software development team leads who are monitoring this at various levels, then it will move from a disadvantage to an advantage area. Next, performance of the entire team or the individual from the team can't be determined. Only the performance of the product is determined. This is a valid goal. So performance of an entire team or individual from the team can't be determined to pinpoint, but the overall performance of the product can be determined how they're moving forward in getting the product to release and getting out to the user. Next, sometimes the quality of the product is not met with the expectation. So when you're doing even the testing phase, you don't have much bugs caught. But at the later on, when we get into a beta testing and getting out to the user, more bugs are caught. Then we see that it is not met with the estimation and the product metrics used were not the right ones. You need to tweak it so you uh, achieve a good result. Next, it leads to measure the unwanted data, which is wastage of time. So if you have more metrics, if you're doing micromanaged metrics, if you're putting in place, so you have more metrics, you don't know what is happening with your old data. You sometimes run to wrong results, and which will cause delay in the project, which will cause problems, bugs, and it will even cause sometimes to uh, revamp the project metrics. That is the thing. Next, measuring the incorrect data leads to making decision mistakes. So if you have incorrect data, your decisions are wrong. So these are some of the disadvantages of the software metrics, like expense, performance of the entire team and individual can't be determined, then quality of the product is not met, incorrect data leading to incorrect decision making. Next, challenges and misconceptions in software metrics. So lack of management commitment, collecting data that is not used, measuring too much and too soon. So one of the misconception is you measure too much and too soon. At the earlier part of the phase, you estimate the software development metrics, and then you uh, make changes in your team or the time for getting them developed. This may lead to uh, measuring this may lead to the inconsistency in the products and measuring the wrong things. This is another challenge that is there. There is no concrete way telling that which are there are a few metrics like lines of code etc which are concrete, and uh, measuring the wrong things, misinterpreting the metrics data. So here we come to the end of the presentation. So this presentation hopefully gave you a idea on different project and product metrics out there used in software project management. Thank you.